Okay, here I'm looking at one of the core bit maths questions, how to find an equation of a perpendicular line. Now, before you watch this video, you need to have a look at the videos that I made on how to find equation of parallel lines. Okay, we'll look at this question. Straight line, they called it K, has an equation. There you go, there's the equation, where the gradient here is 2 and the y-intercept is not 5, it's actually minus 5. I always take care with the signs. Right, there's another straight line, J, and it's perpendicular. Perpendicular means when two lines are perpendicular, that means they are at right angles to each other, 90 degrees, right? So for example, this and this are 90 degrees, right? So J is perpendicular to K. That one is perpendicular to this. And J also happens to pass through -4 and 8. Right? That is not the y-intercept, and I've explained why that's not the y-intercept in a previous video. That coordinate does not even lie on the y-axis. So if any line passes through this point here, it would not be the y-intercept. Find the equation of line J. Right, before I do any more, right, there's one little thing I just need to show you. Right, before I talk about this, let's suppose I've got a number like 2, for example, and I want to find the reciprocal of 2. Reciprocal of 2 is 1/2. Right, how is that? I'll explain. You know that 2 there, I put here, that's the same as 2/1, isn't it? 2 is the same as 2/1. 2 divided by 1 is still 2. It's the same thing. Reciprocal of 2/1 is 1/2. You flip it. So if you had a reciprocal of half, if you want to find the reciprocal of half, you flip it. That's 2/1, which we know as being 2. Right, if you had another one, let's say we want to find reciprocal of 2/3. That's 3/2. Now that's pretty straightforward. Reciprocal of x is 1/x, because we know x is the same as x/1. So if you flip it, you get 1/x. So that explains reciprocal. So when I mention reciprocal later on in the video, you'll know exactly what I'm talking about. Okay, reciprocal. We want to find the equation, right, the equation of J. It's a perpendicular line, and we know all perpendicular lines have the form y equals mx plus c. Its gradient is not going to be 2. If they were parallel to one another, if both these lines were parallel, i.e. same gradient, same steepness, then the value of m would be the same, but it's perpendicular. It's this sort of situation. So how do I find the gradient of a perpendicular line to this one here? Right, we work with this. Right, that's the equation of K. Sorry, that's the gradient of K. And to find the gradient of the perpendicular line to this, what you do, as I've done over here, find the reciprocal of 2. That's going to be 1/2. And then you change the sign. Positive becomes negative. Right? So to find the gradient of the perpendicular line, reciprocal it, and then change the sign. So for example, if gradient happened to be -1/2, -1/2, then you reciprocal the half, 2/1, negative then becomes a positive. You change the sign. If, let's suppose, gradient happens to be just 2/3, yeah? Then what you do to find the gradient of the perpendicular line, you reciprocal it, yeah? Flip it, and then positive becomes a negative. So gradient of a line happens to be that, its perpendicular one, gradient of the perpendicular line would be that, all right? So now, back to the question. The reciprocal of 2 is a half, and then positive becomes a negative. So that would be minus a half. So the m would be minus a half, all right? Right, how do we go forward with this now? Right, how do we go forward with this? I need to find the value of c, where it crosses the y-axis. And what information will help me is this bit here. That's what's going to help me, because that's there for a reason. That's your x value and that's your y value, x and y value. So let's substitute. Y is 8. That stays the same for now. X is what? X is negative 4. So that's going to be times by negative 4, and that's just plus c. Right, let's just simplify this. That's 8. Negative half times negative 4. Two negatives make a positive. Half times 4 is 2. 4 divided by 2 is 2, right? So that just becomes 2 plus c. Right, this you can do in your head. 2 adds something to give me 8. Therefore, c is equal to 6. So our equation of a perpendicular line is finally y is equal to minus half x. What's the value of c we just worked out? There. That's the answer. Okay, this bit I'm about to say is important regarding reciprocal. If there was just a standalone question, okay, never mind this, never mind all this. If there was just a question that asked you to find the reciprocal of 2, then clearly you flip it. Remember that 2 is the same as 2 over 1. You flip it, it becomes 1 over 2. That there is the reciprocal. The half is the reciprocal. Right. What I've just said to you now is just a standalone question, how to reciprocal. But in this situation when you're trying to find the gradient of a perpendicular line of this one, remember this? You reciprocal it, so 2 becomes a half, right? Because we're trying to find the gradient of the perpendicular line, you reciprocal it, but then you need to change the sign. Positive becomes a negative, right? That's the only time you are going to change the sign if it's to do with this kind of work, right? And I'm going to say it again. If it was just a standalone question, not this, nothing to do with this. If it's just a standalone question, find the reciprocal of, let's say, 2, then it'd be just a half. You do not change the sign. You only change the sign when you're dealing with this topic. You reciprocate it and then change the sign. Positive to a negative, negative to a positive, only in this situation, right? But when it's this, just to find reciprocal, you only flip it, right? You need to remember that. So do not confuse the two things, right? Okay, another question. Let's suppose we want to find out the equation of a line parallel to L, that one there, which is given over here. Right, you see that better now. Write down the equation of a line, and I'm assuming it's any line, which is parallel to this. So there could be many different lines parallel to this one, all right? So definitely, for one thing for sure, is that m will be same gradient minus a half. Do it in a different color. So it'll be y is equal to minus half x, and it could be any intercept, so it could be any number. Just make something up, I don't know, 7, minus 7, whatever, all right? So any number here, as long as you've got a gradient of minus half. Right, can I just say one more thing? Right. Some people seem to think that if the question asked, what's the gradient of this line here? People write down minus half x. Well, that's wrong. Now it's right. That's the gradient part. That there is the gradient part. Minus half with an x It's not the gradient. It's just the number. It's just the coefficient of x, the number in front of the x. That's the gradient. Right, next question. Find an equation of a line that goes through the point 1, 6 and it's perpendicular. Perpendicular. It needs to be perpendicular to this line, going at right angles this way. So one thing for sure is that its gradient is going to be the reciprocal of this. Right. The reciprocal of this is, well, first of all, the reciprocal of a half is going to be 2/1. Right, 2/1. And the negative changes to a positive as it is. So the reciprocal of a half is 2, but the negative changes to a positive. That's what you do for this type of work, right? But remember, as I've said, if you want to find the reciprocal of just minus half, that'd be minus 2/1, okay? Or just, you could just say minus 2. That's a different situation. That's got nothing to do with this work. But here, negative changes to positive, or a positive changes to negative after you've reciprocaled it. So that's going to be 2 for the perpendicular, right, situation. So we've got y is equal to 2. Where did that 2 come from? Right there. X plus something. Right, what do we do with this information here? It's there for a reason. If you're not using it, then you're not doing it right. That's your x and that's your y. So guess what we're going to do with the x and y? There's only one thing to do, is plug these numbers into these letters. So y is 6, 2 is there, and x is, what does that say? 1. 2 times 1 is 2. Right, therefore c is equal to 4. So our equation of the perpendicular line is y is equal to 2x plus 4. I could take this question just one step further. Now you know this one here, which I've just found out, that's the equation of the perpendicular line. Its y-intercept is 4, so obviously it crosses here and it goes that way. It's perpendicular at right angles to this line. What if I wanted to work out, not by drawing, but I wanted to find out where this graph, linear graph, crosses the x-axis, the x-intercept. Right? So it crosses it somewhere along this line, somewhere along this line. But where exactly? And I don't want to draw it. I want to find that using algebra so I can be accurate. Right? It might be difficult to draw a right angle, a line that's going perpendicular to this. That could be a challenge. So what do? Right, wherever it crosses along here, right, the y value, wherever it crosses, the y value is going to be 0. 0 up the stairs, look, it's 0 up the stairs here, 0 up the stairs, 0 up the stairs, all along here. So we know y is going to be 0. Right, if it crosses here, here, we don't know where it's going to cross, but one thing we know, that the y value up the stairs is going to be 0. So what do we do now? Using our equation over here, because we're related to this one, this is what we found out from part B. We know y is 0, we want y to be 0, right? We want y to be 0. 2 is 2. X, we don't know what it is, but we're going to find out, and that's just plus 4. So that's going to be 0, 2x plus 4. So what you do now is to get x by itself, take away 4. What do we do on this side? Do it on the other side. Zero take away 4 is minus 4. 4's cancelled, you got 2x on this side. Now, to get rid of times by 2, you divide by 2. What have you done on this side? Do it on the other side. Negative 4 divided by 2 is negative 2. So x is equal to negative 2. X is equal to negative 2, negative 1, negative 2. right there. So the line goes like this. Right. Can you think of why these two lines, the red one and the green one, don't look right angle? Right? They don't look right angle. There's a reason for that. I mean, the diagram itself, it's fine, but there's a reason why it doesn't look right angle. It's because if you look at the scale over here, right, that's 1, that's 2, 3, right? So these are going up in 1s like this, whereas here it's going up in 2s, 2, 4, right? So the graphs look a bit skewed,